Hello friends, in this video I'm going to show you how you can calculate your reaction time. If you go to the Air and Space Museum in Washington, DC, there's a little exhibit where you can test your reaction time. They have a stick that looks kind of like this, and it's hanging from a magnet, and at some random time it drops, and you've got to try to catch it. You keep your hand in place and you see if you can catch it. And then along the stick there are times marked out, and you can see what your reaction time is. You can do that same thing using physics, using a basic calculation in physics and a meter stick. So here's how it works. We take our basic position or displacement function, depending on how you solve it. So delta x equals v naught, that's the initial velocity or the velocity at time 0, times t plus 1/2 at squared. Since we're dropping a meter stick, it's being dropped, so the initial velocity is 0. It's being dropped from rest. And the acceleration is the acceleration due to gravity, 9.8 meters per second squared down. And so when we put this information into the equation, we get delta x is 1/2 gt squared. You can call this delta y or h because it's vertical if you want. It doesn't make a difference in the end. And then solve for t. I spared you the algebra, and I got it to this point. If you solve for t and you want to do the algebra yourself, this is what you should get. So now what you do is you take the meter stick and you have a friend drop it for you. You can't do it yourself because then you know when you're dropping it and it's going to mess up your reaction time. And you got to leave your hand in place. You can even put your hand on the edge of like a table or something so you're not dropping. You got to leave your finger in place. They drop it, and then you just have to see how far it falls. What's the displacement? What's the vertical displacement of the meter stick? So if you're at the 20 or the 30, right? If you're at the 20 and then you drop it and you catch it at the 50, then the displacement was 30 centimeters. So you take that, have someone drop the meter stick, record how far it falls, convert that to meters. That's important, otherwise it'll mess up the calculation. Sometimes my students tell me their reaction time was like 1.5 seconds. I'm like, that was not your reaction time. It would have fallen through the floor by then. But, so make sure you convert it to meters. Whatever number you get, so if it's like 0.3, then you put it in here. Or do this a few times, take the average, and then put it into here. Divide by 4.9, take the square root, and that'll tell you what your reaction time is. It should be usually in the order of 1/10 of a second to a few tenths of a second. That's kind of normal reaction time. So in the comments below, you can put what your distances were, tell us what your reaction time is, try it out. Thanks for watching. Don't forget to like and subscribe.